The broadcast is now starting. All attendees are in listen-only mode.
Hi, and welcome to our webinar. For our Step in the Security series today, we'll be presenting information on IP security camera techniques for video surveillance. My name is David Martin, and I'll be your moderator today. And I'll give you a little background on LENSEC. Since 1998, LENSEC has been a trusted security and surveillance partner with experience in the USA and around the world. LENSEC has a background working with many types of industries. We help customers develop enterprise solutions for complex physical security products. We've developed a powerful security platform called Perspective Video Management Software. This is an enterprise VMS that streams and captures IP security video and incorporates video analytics, access control, and more into the software. I'll introduce our speaker in just a moment, but first I need to go over a few logistics for the webinar. We will be taking questions during the webinar. You can enter your questions in the GoToWebinar panel. It's at the bottom of the panel. We'll collect those during the presentation and answer questions at the end of the event. We'll also present poll questions during the event, and we encourage your participation in answering the questions as they are presented. At the end of the webinar, we'll present a survey for attendees. We'll ask that you answer a few questions to help us better serve you in future webinar events. If you're interested in completion certificates for today's webinar, just indicate your wishes on the survey. We'll follow up in a few days after the webinar with certificates, answers to questions, and a copy of today's presentation. Also, we record these webinars. We post them on our website, and we'll provide you with a link to the webinar video archive. You can find it at lensec.com. LENSEC sponsors these webinars monthly, and we cover a variety of safety and physical security information. So check back with us often to find out what's coming up next in our Steps into Security webinar series. Today's physical security expert is Keith Harris. He is the marketing manager for LENSEC. Keith has experience working with customers recommending video surveillance solutions. This includes training law enforcement personnel on video surveillance investigation techniques. And Keith has spent many years in the broadcast news industry as a photojournalist and has worked in the video security industry for the past 10 years. So join me in welcoming Keith.
Thanks, David. I certainly appreciate everybody joining us today. We're going to move rapidly through our goals today and try to save a little time at the end to answer questions. However, if you do have questions that we don't get to, we'll respond to you by email after the webinar with answers for you. So let's get started. The price of IP cameras has been dropping steadily over the last several years, but it's still common to see analog cameras everywhere you go. The analog cameras are an older technology by today's industry standards, though some are still used in legacy systems. As the digital revolution has led to IP megapixel cameras replacing older analog camera technology, higher resolution images are available in megapixel cameras, and they are the primary driving factor in replacement. Let's jump right into our first poll question. David, do you want to handle that for us?
Yeah, I'll get that launched for us. The first poll question is, do you know the difference between NTSC and PAL? You can select from the following just by clicking the bubble. NTSC is a video format and PAL is a power format. They are interchangeable. NTSC is a video standard developed in the US and PAL is a video standard developed in Europe. And the last answer is, I have no idea. So we'll give you a few moments to make your selection, and we'll show the results there. Okay. Looks like half and half, 50% just weren't sure, and 50% have answered correctly.
Yeah, so NTSC is a video standard developed in the U.S., and PAL was developed overseas. Analog cameras provide video to display or a recording solution at a limited resolution. The standard set forth by NTSC limits cameras to 720 by 480. otherwise known as D1 resolution. The PAL standard is very common in Europe and other locations, as you can see on our map here. A lesser-known standard is called CCAM, used in France, parts of Africa, and Russia. Both of these standards cap resolution far below the current standard for video. With recent transitions to digital video capabilities, the security video industry is responding with megapixel IP cameras providing much better resolution. This improves the images significantly over the standards set back in the 40s and the 50s. The way video is transmitted shows up in the physical appearance of the camera. If you'll take a look at the back of these two cameras, our analog camera on the left has a female BNC connection that connects to a coaxial cable. The key differentiator for the IP camera is the addition of a NIC card, allowing the connection of an Ethernet cable. For the sake of time, we're not going to spend much time discussing analog cameras or a new technology called HD analog, which is a growing option in the physical security industry. But instead, we're going to focus on IP and specifically megapixel cameras. IP or network cameras have imaging systems with the same basic elements as the analog camera. We'll go over the imaging system in a moment, but first, let's look at the unique capability of an IP camera. The primary form of transmission for these cameras is across a computer network. The network device is connected to a switch via an Ethernet cable. Today's IP cameras are usually powered by the network switch with power over Ethernet, also called PoE. The processing of the camera image happens in the camera, and this is important because it takes the load off of the video server, reducing the processing power needed to capture and store the data. Advancements in IP camera chipsets and camera components are rapidly improving, making cameras with resolutions exceeding 12 megapixels available. Cameras may be within 328 feet of the network switch providing PoE power. Longer distances could be achieved by boosting power with a PoE injector or a mid-span injector. And I've heard some cases of cameras reaching distances longer than 328 feet, but for the sake of the specification and a conservative approach, always plan to add an injected power when you get longer than that distance. IP camera settings are usually accessed by a web page that the network camera will generate. Users can change camera settings and access advanced features using a web browser via the network. And looking at some advanced features here within the camera, since IP cameras are essentially computers, one of the added advantages is edge storage in some cases. Most IP cameras may have an SD card slot and firmware within the camera that can be set to record video locally on the camera. This can be helpful in certain situations, such as investigative work where no remote viewing is necessary, or you could use it as a backup to the primary recording system. Setting the proper camera view can be helpful in getting the right video evidence recorded. A few unique camera setups should be considered. Let's look at this hallway here. In a standard landscape view, a video area can be wasted on blank wall space. When you use a camera that has a corridor view available, it provides a unique space ratio capturing more of the key video area. Corridor view allows cameras to maximize video surveillance in narrow vertical situations. This format creates a unique vertical video. Traditional high-definition video is recorded in a horizontal or landscape format that's wider than it is tall, with a ratio of 16:9. The new corridor format creates a vertical portrait video with a 9:16 aspect ratio that works well in tall, narrow spaces. This helps avoid recording unnecessary space where useful activity rarely occurs. A panoramic view camera is a different way to approach achieving coverage of a wide area. I've got a few examples displayed here. The first is a camera configured to cover an area 360 degrees around the camera seen in the top left picture. It can show a view as displayed in one camera viewer, like the view on the upper left, though that's not a common display technique. More often, you'll see the camera view split up and de-warped to show 4 separate views or a quad view, such as the picture on the right, upper right. This only uses one camera stream and license to achieve 4 camera views looking out 360 degrees from the camera position. The next example at the bottom of the screen is a high-resolution 180-degree view. This is a wide-angle view in a panoramic format. However, the difference is the view displayed here is just using one camera. The user can digitally zoom in on the high-resolution image to capture activity across the panoramic view. Not all cameras are equal in terms of body style. However, the body styles are usually designed with function of the environment in mind. Indoor cameras are usually stripped of some features and durability in order to reduce the cost. If a camera is only rated for indoor use, it usually doesn't have proper weatherproofing to endure over time. An outdoor camera will have added features that prevent intrusion by moisture and dust. They're often constructed of more durable materials and have gaskets to prevent moisture and dust particles from damaging the electronics. Camera housings can be used to protect an indoor box camera in an external location. This will render an indoor camera weatherproof. The camera housing may have a heater or a blower in it. A heater element usually keeps the camera housing warm, melting frost or ice off of the lens cover so that the view will still remain clear even in extreme conditions. The blower dissipates heat and humidity for a camera in a hot environment. Most cameras tend to be more temperamental in hot weather than they would in cold weather. If you're using a camera housing with a heater blower, you want to make sure you have proper power at the camera position. Most housings run on 24-volt power, though there are a few on the market that are powered off of a PoE switch from the network, just like your camera. If you want to make sure, that you run a power budget on your switch to make sure it will support the added power equipment if you're adding a housing in. Outdoor cameras have a specification called an IP rating. This has nothing to do with Internet protocol like the data transmission from an IP camera. Instead, IP stands for Ingress Protection. The IP rating is a measurement of the device's ability to block intrusion by dust and moisture. The first number in IP rating is associated with the dust intrusion of the housing. The second digit references the camera's ability or inability to block moisture from the camera housing. Most camera housings today are IP65 or better. An IP65 rated camera housing is dust tight and will survive jets of water with limited ingress. IP66 is also dust tight and survives jets of water with no ingress. IP67, dust tight, and will survive an immersion in water to a certain degree for a limited period of time. And an IP68 camera means the housing is dust tight and immersion in water under pressure for long periods of time is allowed. Here's several different types of camera body styles that can be used in different scenarios. On the bottom left, we have a CS mount box camera. The letter CS remounts to the lens that is interchangeable on the camera. This type of camera is usually used indoors or in a camera enclosure for outdoor use. These are popular if you have to change the lens on a camera to a non-standard focal length. Bullet cameras, like we see on the upper right, are typically ready for outdoor mounting in their own housing. The term bullet refers to their oblong shape. These sometimes come with sunshades to keep the lens shaded and avoid glare on sunny days. They may also have infrared illuminators built into the camera housing that can illuminate an area within the camera field of view and no external lighting provided. Dome cameras in the center are very popular for both indoor and outdoor use. They sometimes have infrared illuminators built in and are usually ceiling mounted. If you have to wall mount them, you may want to consider a mounting arm that fits the base of the dome. They can be turned on their side, but that will affect the picture angle. A dome with a tri-axis capability gives you the ability to manually pan, tilt, and rotate the camera head to achieve the proper image orientation and field of view. PTZ cameras, shown here on the bottom right, have a mechanical ability to manipulate the camera angle and direction. So this allows a user to remotely pan, tilt, or zoom the camera to achieve the view they desire. They also have the mechanical zoom ability that physically changes the focal length, allowing you to zoom in or out on the intended target. Now it's time for poll question number 2.
Okay, I'll prepare that for us. The question is, what is helpful in order to capture a usable license plate image? And you can choose from the following: illuminating the plate at a correct angle to avoid glare, zooming to a 10-foot horizontal field of view, use a camera designed to stop action at vehicle speed, or all of the above. And we'll give you a few moments to make your selection. Okay. Looks like everybody's made their choices, so let's look at the results. And all of the above, 100%.
Well, everybody got it right, so we are right on path here. Let's take a look at the license plate cameras in particular. These are not your basic cameras. They have special features making it easier to read plate numbers in spite of the reflective nature of the license plate. Where a typical camera might not be able to make out the plate due to glare, license plate cameras adjust to compensate, making the plate numbers more readable. Images may not provide good details of the rest of the scene because the exposure is set to optimize the clarity of the plate numbers. If you need additional detail of the scene when you're capturing a license plate, it's recommended that you use another camera in conjunction with the LP camera in order to maximize the detail you require. Some security integrators will rely on megapixel cameras to get the license plate detail, though if you want to go that route, make sure you have enough light at the LP capture zone in order to get to the detail you require at night. Also, narrowing your field of view at the capture zone will enhance your ability to be able to make out the license plate detail. Placing the camera at a choke point where traffic narrows and slows down helps with the ability to be able to capture your detail as well. Covert cameras are micro board cameras that have a very small footprint. These are useful for investigations and to cover perceived blind spots where the camera will be undetectable. Some IP camera manufacturers have developed megapixel IP cameras which can greatly enhance your surveillance video. Thermal cameras, such as we have here at the center of the screen, use advanced imagers and lenses to capture an image displaying a heat signature. Such as the example we have here, these are used to cover perimeters or areas where lighting is difficult or impossible to achieve. The camera will record the heat signatures as opposed to standard video images. Some cameras come with audio built in. This has been my experience. Some cameras with microphones have very poor audio quality, though that could improve significantly with better cameras. The Axis M50 series here has a built-in microphone that's very good. What I'd recommend is you make sure you have a chance to check the audio quality before you make your final decision on using a built-in microphone, because your microphone sensitivity and capability could vary from location to location. Some cameras have audio connectors that allow you to connect an external microphone. This is usually preferable because you can add a high-grade audio system such as the LaRue microphone shown here at the top of the page. Now, there have been two types of camera sensors on the market for several years, CCD and CMOS. CCD stands for Charge Coupled Device, and the camera sensors have long been the industry standard for cameras. Many have said that CCDs had the edge on low light capability in their day. However, Sony discontinued its line of CCD camera sensors, and CCD's day in the sun seems to be over. It's time to focus on the future of CMOS sensor technology. CMOS stands for Complementary Metal Oxide Semiconductor. The CMOS camera sensors have been used for a while as an alternative choice. The chipset has the distinction of providing a smaller sensor, meaning the camera can be much smaller. Recently, CMOS sensor technology has vastly improved. These sensors now have great low-light features and provide excellent resolution. CMOS sensors are also doing a great job in helping to bring down IP camera costs overall. There are two imaging scanning techniques for reading and displaying information produced by image sensors. Interlace scanning is used mainly with CCD sensors and is not as relevant today. It's a technique for doubling the perceived frame rate of a video display without consuming extra bandwidth. The interlace signal contains two fields of a video frame, odd and even lines, captured at two different times. This enhances motion perception to the viewer while limiting bandwidth consumption. One field contains all odd lines in the image and the other contains all even lines. But you can see when you pause the video to capture a still frame, you don't have much definition within just one of the fields and not necessarily both of them intertwined. A progressive scanning takes you to the next level. It can be used with either CCD or CMOS sensors. With the progressive scan image sensor, values are obtained for each pixel on the sensor. Each line of image data is scanned sequentially, producing a full frame image. In other words, captured images are not split into separate fields as with interlace scanning. With the progressive scan, each line of the image is sent one at a time in order. Moving objects look better on the computer screen using the progressive scan technique. You can see that here on the left of our example. In a video surveillance application, it can be critical at viewing details of a moving subject, such as a person running away. That would use more bandwidth, the progressive scan. However, there's more bandwidth available for cameras today, so the trade-off is definitely worth it for the better image clarity achieved. A camera's automatic exposure tries to get the brightness of an image to appear as the human eye would see the scene, but cameras can be easily fooled. Strong backlight can cause objects in the foreground to be dark. So cameras with backlight compensation try to ignore the limited areas of high illumination, just as if they were not present. The backlight compensation would enable the objects in the foreground to be seen, although the bright areas might be overexposed. In some advanced network cameras, the user is able to use exposure zones to set the area of the scene. So you would divide the image in the center, left, right, top, or bottom. And that might help you to be able to make adjustments to expose the image more correctly. Wide dynamic range is a camera sensor feature that handles a wide range of lighting conditions in a scene. In the scene, with an extremely bright or dark areas, or in backlight situations where a person is in front of a bright window, the typical camera produces an image where objects in the dark areas might hardly be visible, such as we see at the bottom of the screen, our example in the middle. Wide dynamic range solves this by applying techniques such as using different exposures for different objects in the scene. That enables objects both in the bright and dark areas to be visible, achieving a better exposure overall. So noise reduction is image noise that is interference in the video. And that signal would show up as a grainy specks in the video to show up, just such as we see here on the example on the right. It can be caused by low lighting situations, nearby power interference, heat, etc. Many different things might cause that. Digital noise reduction is a technique of removing image noise from the video signal by applying a digital comb filter. That makes the image clearer and reduces the image file size. A 2D filter reduces noise that can be found in low light image. This type of filter can sometimes be confused by motion, resulting in blur trails in the video. So a better technology is 3D NR filter. This one goes one step farther and effectively reduces the noise in static images and images with movement. We made lots of references so far to high definition or megapixel resolution. Let's take a moment to explain that. Megapixel is 1 million pixels. It's commonly used to indicate the resolution of a high definition surveillance camera or a display monitor. A pixel is a tiny square in a digital image. The image is actually a grid of these pixels. If you greatly enlarge a digital image, you can see the actual pixels. Or if your image is at a lower resolution than your viewing size, the pixels are visible as in our pictures here of the bear on the screen. The higher resolution, a higher number of pixels, the clearer your resolution or image will be. Common megapixel sizes include 1.3 megapixel, 2.1 megapixel, 3 MP, or 5 MP, or even higher. For example, a 1.3 megapixel image commonly is made up of 1,280 pixels wide by 1,024 pixels high, or 1,310,720 pixels. In other words, 1.3 million pixels. The higher resolution video streams generated by a megapixel camera also put higher demands on the network bandwidth and storage space for recording. This can be helped by using an H.264 video compression standard. We'll go a little bit more into the compression standards coming up. Megapixel network cameras deliver images with 1 million or more pixels. That's twice the pixel resolution provided by analog cameras at a minimum. Resolution advances continue to break the barrier in security video definitions. A megapixel fixed network camera can be used in one of two ways. It can enable viewers to see greater details in a higher resolution image, which would be helpful in identifying people or objects, or it can be used to cover a larger part of the scene if the image resolution is kept the same as a non-megapixel camera. This image was taken with a 5 megapixel camera. When you consider the field of view, a higher resolution camera can capture the full scene at high detail. A camera with limited resolution would need to be zoomed into a tight shot to capture the same amount of detail. To capture the entire scene and achieve the same level of detail, you would need several cameras. Even an analog PTZ camera with this scene couldn't capture the same level of detail without eliminating part of the field of view. A megapixel camera can be zoomed back to capture the entire scene with one camera. The digital zoom can zoom in on specific areas while the camera is still capturing the entire scene. Now, 4K resolution has been all the rage lately. These cameras are the latest, greatest technology in IP megapixel cameras these days. Historically, total pixel count has been the most common method for naming resolutions. For example, 1 megapixel, 2 megapixel, etc. You've probably also heard people refer to the resolution by the vertical pixel count. For example, 720p, 1080p, etc. Now, the newest naming convention is identifying the resolution by the horizontal count. For example, 2K, 4K. The number with a P refers to the total number of rows in the video. A 1080p video feed is 1,080 rows of pixels. The number with a K refers to the total number of columns in a video. A 4K video feed has roughly 4,000 columns of pixels. Technically, most surveillance video has 3,840 rows in an ultra-high definition or UHD video. MP or megapixel is the total pixel count. The P value is multiplied by the K value to get the total pixels. For example, 1,920 columns multiplied by 1,080 rows equals roughly 2.07 MP. Most people call the resulting value 2 megapixel or 2.1 megapixel. In short, using a 4K camera in place of a 1080p camera will roughly double the pixels per foot in the scene. This means you'll be better able to make out facial details or a license plate in comparison to a standard camera or a lower grade megapixel camera. This Axis camera can provide 8.3 megapixels at 30 frames per second. Manufacturers are pushing resolutions up to 12 megapixels, and Sony has even announced a 20 megapixel surveillance camera. 4K cameras allow for increased detail and coverage area. The potential here means you have the chance to reduce the number of cameras needed to adequately cover an area. That equals lower system and installation costs, but it's not a magic bullet either. On the negative side, you'll have increased bandwidth and storage needs. Your load on the server and the client will be increased as well. In addition, you may have reduced performance in low light, depending on the camera that you choose. And your frame rates and video streams could be affected due to the higher resolution. The industry standard for security cameras provides an ability to achieve your desired resolution with 30 frames per second. Some 4K cameras don't deliver on this. In other words, a camera may be able to provide 4K images, but you might have to drop your frame rate to 15 FPS in order to get the highest resolution. So there's a trade-off. When you're choosing a 4K camera, make sure your video management software fully supports the high resolution. Also, monitors you're using to view the live video stream or the recorded video will need to provide the appropriate resolution in order to see the level of detail that you require. Low light sensitivity is defined as the lowest level of light that still provides reasonable video clarity. Most cameras will work well in normal room lighting, but we have to look at the specifications to see if the camera will work well when it's dark. Illuminance is the measure of how much lux is spread over a given area. Lux is the measurement of actual light available at a given distance. It stands for luminous flux, and the measurement of 1 lux equals 1 lumen per square meter. A given amount of light will illuminate the surface more dimly if it's spread over a larger area. So, illuminance is inversely proportional to area. Specifications for video cameras usually include a minimum illuminance level in lux. The lux is the measurement at which the camera will provide a satisfactory image. A camera with a good low light capability has a lower lux rating. Color cameras are not very sensitive in low light by their very nature. They don't pick up light well within the infrared spectrum. This helps to maintain less glare and also improve color clarity of the image. Black and white cameras, however, have been a workhorse for low light imaging. The black and white camera can pick up the infrared light spectrum and see better in areas where lighting is poor. They can often pick up details of a scene when a color camera is only seeing black. This is why day-night cameras were developed. A day-night camera uses a color image in the day. When lighting conditions change, the camera light sensor will detect the change, and the camera will switch automatically to a black and white image. Cameras will typically achieve this function using digital day-night, a firmware feature, or they may have a mechanical cut filter that provides true day-night clarity. This scene shows what can be achieved with cameras using ambient white light. At night in black and white mode, the image on the right looks quite good considering there's no infrared. It's just an ambient light from across the street and porch lights by the garage that's illuminating this scene. Infrared light is a way to supplement a camera scene with artificial light. When white light isn't available, you can flood an area with infrared light that the camera can see, but it's less visible to the human eye. Some cameras have infrared illuminators built into them. These emit a slightly visible light between 840 nanometers to 880 nanometer frequencies. This is not visible to flood the scene with light, but the noticeable red glow will be visible at the camera position when the illuminator is active. If you have an area of concern and don't want a visible red glow, you might want to consider an illuminator with an infrared frequency at 940 nanometers. That light is invisible to the human eye and shouldn't be detectable. There's only a few cameras with 940 nanometer LEDs built in. Most of the time, you need to supplement with an external infrared illuminator that provides 940 nanometer light. Recent technology being offered in some cameras with infrared is called Smart IR. This is infrared that can read the camera image and adjust the power to the IRs in order to avoid blowing out the target area. Infrared that's too strong in the target area will display as a bloom in the video, such as what we see in our picture on the bottom left. And when you have a bloom in the video, it makes features undetectable. Smart IR helps to adjust the end result and provide a more usable image even when the subject is close to the camera. Now let's go back to our car in the driveway here. Whether you have a technology called light finder, light catcher, light grabber, or something else, there's several different advanced camera systems that include light enhancing technology built into the camera. Light enhancing technology is a combination of image processing, chip development, and selection of the best optical components. Cameras with this technology have extreme light sensitivity. Such cameras can deliver color images in almost zero light conditions. Compared with any analog or network cameras, the light enhancement will give more lifelike colors in low light conditions. Noise reduction is vastly improved compared with standard surveillance cameras. In fact, these newer cameras can provide color images in nearly no light at all. The display seen on the left is using a camera that has switched over to night mode. The picture on the right is using a camera with light finder technology, which is still functioning in daytime mode. You can see this will provide a color image and details with excellent clarity, even though it's night outside. Gain control is a critical factor in low light surveillance video. It's generally only noticeable when the negative side effects of gain levels are seen, namely noise or snow on the screen. Noise is displayed as graininess in a low light image. Ideally, you should attempt to achieve the lowest gain for a light image that you can achieve without noise in the picture. Your gain is measured in dB. The range tends to be from 0 dB, which is off, to 30 dB, which is an extreme setting within the camera. Most cameras would have an AGC, or automatic gain control. This means the camera gain will automatically be controlled by the camera. Surveillance camera manufacturers tend to choose an aggressive gain setting to control an image's appearance in variable lighting conditions. Shutter speed also affects your image. The shutter speed indicates how fast the shutter opens and closes in a second. If your camera shutter speed is set to 1/20th of a second, then you won't be able to achieve more than 20 frames per second, even if your recorder is set for a higher frame rate. The longer the shutter stays open, the more light gets to the camera imager. However, lengthy shutter speeds mean that movement, in particular fast movement, might be blurred in the captured image. A faster shutter speed will stop the action better, but more light will be required on the scene. Now, some cameras provide a digital slow shutter, which is called DSS, or another feature called Sense Up. These are basically interchangeable terms. Different camera manufacturers use different terminology for this feature. The tech here is a camera feature allowing the user to select a slower shutter speed than is typical in security cameras in order to let extra light into the camera. This provides a higher sensitivity in low light conditions and may eliminate the need for artificial light. In fact, it can improve an image that has little or no light at all, allowing the user to see in near total darkness. However, there's a high possibility of significant blurring in the image as your setting is increased, and fluid movement will be affected as well. Most professional IP cameras today are designed to stream at up to 30 frames per second. So 5 frames per second displays a very jerky video. However, it doesn't use very much storage space at all. 10 frames per second is less jerky and only use one-third of the storage space needed for full motion video. 15 frames per second is about the industry norm. The video displayed is relatively smooth and requires half the space needed for full motion video. 30 FPS will provide smooth video and capture the most detail. However, it consumes the highest amount of storage space. So you'll have to pick and choose based on what your needs are in specific locations. Video compression technologies remove redundant video data so that a digital video file can be sent over a network and stored more efficiently. With compression techniques, a significant reduction in file size can be achieved with little effect on the visual quality. Let's look at 3 different video compression standards: Motion JPEG, MPEG-4, and H.264. With the Motion JPEG format, the 3 sequential images are coded and sent as separate unique images or frames with no dependencies on each other. MJPEG, or Motion JPEG, is a digital video sequence that's made up of a series of individual JPEG images. Video compression algorithms such as MPEG-4 and H.264 use interframe prediction to produce video data between a series of frames. This involves a technique called difference coding. This is where one frame is compared with a reference frame, and only pixels that have changed with respect to the reference frame are encoded. So look at our example here. The house doesn't move, so it doesn't have to be captured in every frame. They're just displayed again and again and again from the reference frame. The person, however, is moving, so the pixels that have movement are captured in every frame. In this way, the number of pixels transmitted each time is reduced. The end result will look the same to the person viewing the video. MPEG-4 supports a lower bandwidth application and applications that require high-quality images with no limitations in the frame rate. H.264 has become more of the industry standard. Compression can be help to reduce the size of the digital video file by 80% when you compare that to an MJPEG without compromising your image quality. It can reduce video as much as 50% more than an MPEG-4 standard. So this means much less network bandwidth and storage is required to transmit the video file. The process of compression involves algorithms that encode the source video to create a compressed file that's ready for transmission or storage. To play the compressed file, a paired decoder is applied to a produced video that shows virtually the same content as the original source video. An encoder-decoder algorithm pair that works together is called a video codec. Video content that is compressed using one standard cannot be decompressed with a different standard. For instance, an MPEG-4 decoder does not work with an H.264 encoder. Bit rate is the number of bits per second that can be transmitted along a digital network. Some network camera deployments are concerned with limited bandwidth or storage, so that might use a constant bit rate, CBR. With this mode, a user can predefine the bit rate. However, when there's increased activity, the video image may degrade due to the limitation. So they limit the camera's bit rate, resulting in low image quality. Other deployments are not concerned with bandwidth and allow for an unlimited bit rate. This is called variable bit rate, VBR. This allows bandwidth use to increase when there's a lot of activity in a scene, and it will decrease when there's no motion. This is often desirable as video surveillance applications, especially where there's a need for high quality video, particularly if there's motion in the scene. So they'll use a variable bit rate. Now let's take a look at lenses. An important thing about lenses is the focal length. Fixed or varifocal lenses describe focal length in millimeters. This is usually displayed on the lens body. The smaller number, the wider the camera angle is going to be. The larger the number indicates a tighter field of view, consequently a smaller viewing area, potentially at a distance. Let's take a look at this image. This was captured at 12 millimeters. Our target is 100 feet distant from the camera. When we zoom that in, the same target, 100 feet distant from the camera, is seen in this image through a 60 millimeter lens. Now it's important to bring up here, as you're reading license plates, we've talked about that a little bit earlier, but I'll bring it up again. Typically you need a horizontal field of view of 10 feet or less to be able to read a plate, unless you have an LP camera that's designed with better capabilities or a megapixel camera. Thus, at 100 feet, with a 1/3 inch standard camera imager, you'll need a 50 millimeter lens to get a horizontal field of view of under 10 feet. This doubles to 100 millimeters for your lens at a distance of 200 feet and so on. There are several different types of camera lenses available. However, most CCT cameras use the CS mount lens. CS mount lenses are sized based on the distance from the back of the lens to the camera imager. Most cameras sold today use a CS mount lens that's interchangeable between certain types of cameras. A fixed lens camera has only one focal length. The fixed lens has no mechanical ability to change the focal length or adjust the focus. It's fixed. A varifocal lens has an adjustable focal range and is more versatile. An example would be a 2.8 to 8 millimeter lens that has a wide focal length of 2.8 millimeters and a zoomed focal length of 2.8 millimeters. This camera gives you a zoom and a focus ring for manually adjusting the field of view and focal point. When you're using a megapixel camera, you have a megapixel lens that's appropriately rated. An additional lens element would be a manual iris lens that would have an iris ring on it. This is a manual, a mechanical lever that manually changes the iris setting it changes the iris setting of the camera from wide to tight. The iris is an opening in the lens that allows light to pass through the lens elements in varying amounts. An auto iris lens makes the mechanical adjustment automatically and very rapidly depending on lighting conditions. This is an ideal choice for a camera positioned in an outdoor environment. With rapidly changing lighting conditions such as clouds moving across the sun, the auto iris can react much more quickly to adjust the image. This helps to achieve the proper exposure faster than the automatic gain control on the camera can react. When you're deploying a camera in an outdoor environment, it's wise to use an auto iris lens. It avoids lagging exposure due to a slow automatic gain control. When you're using a day-night camera, it's important to use a spherical lens. When you're using a standard lens during the day, a camera image may be sharp and in focus. However, when a camera changes to black and white during the night mode, the camera may lose its clarity and focus. And a spherical lens is shaped differently than a standard lens, and it allows the camera to maintain a sharp focus whether the camera is in day mode or night mode. Now it's time for poll question number 3, David.
Okay. And poll question number 3, how does f-stop affect an image? It tells the recording when to stop. It indicates how many frames of video fill 1 second. This is familiar to me, and I know what to expect. Or it tells how much light will pass through the lens aperture. And again, we'll just give you a few moments to make your selection. And 100% it tells how much light will pass through the lens aperture.
Very good. Everybody's fast on the trigger with the polls today. That's good. We're moving quickly, and we're coming to the exit ramp on our webinar. So we'll get to some questions in just a few moments. The f-stop of a lens is also called the focal ratio or relative aperture. The description here that I've got is quite technical. The main thing to keep in mind is the lower the f-stop number, it allows more light to pass through the lens. The higher number restricts the amount of light passing through the lens. Usually a video surveillance lens will have a low f-stop to allow the maximum amount of light to pass through the camera sensor. Let's take a look at our example here. Looking through the lens, you'll see a low f-stop yields more light, and a high f-stop yields less light. So it's pretty simple. When you're calculating your field of view from a security camera, it's important to know some key information. The most important fact is to know the distance from the camera to the target. That's where we see in our example here where we have the D in our diagram. Most CCT cameras use a 1/3 inch image sensor, and that'll be listed in the camera specs. With a camera that has a 1/3 imager, should have a 1/3 inch lens mounted on it. So that's another important factor that comes into play. The next thing we look at is the vertical height and the horizontal width of the area that you desire for your image. Now, a lot of people will use an online calculator to determine the field of view. Call me old school. I still pull out my trusty CCTV field of view slide rule. But I've provided a LENSEC calculator on the link here that you can follow through to get your calculate your field of view and calculate what your needs are. Let's jump over to power techniques. Volts and amps have a unique relationship. Security cameras are typically 12 volts, 24 volts, or dual voltage. When a camera is running on power over Ethernet, the power is coming through the network switch, and you don't have to worry so much about voltage issues. But when you're using an external power supply, you need to remember a few other concerns. Remember first, though, the camera running on PoE can be up to 328 linear feet from the switch before you have to inject power. Now, when you're talking about power from a separate source, whether it be 24 volts or 12 volts or dual voltage, power can drop over a distance. Voltage can drop over a distance. Your higher voltages, such as 24 volts AC, are more dangerous, but you can run power longer distances before your voltage starts to drop. Power that's 12 volt DC is less dangerous to work with, but it drops faster over distance. Usually you want to find power within 100 feet of the camera when you're using 12 volt power. Certain things come into play in determining your voltage drops: the power draw of the equipment, the length of the cable run, and the gauge of the power cable. It's best to find an online voltage calculator to determine voltage drop for longer power runs. If your voltage drops below the recommended level of the attached equipment, it can damage over time. Now let's take a quick look here at recording space and bandwidth space. We used to use a figure of about 1 gigabyte of recording per hour in analog recording. With IP megapixel cameras, there's a lot of variables that come into play, so that old number gets thrown out the window. With IP calculations, you need to know your camera resolution, your video compression type, video quality settings, frames per second, number of cameras, estimated recording lengths such as 30 days, 60 days, etc., desired bit rate, and even those variables might change per camera. So if you're running a big deployment, you've got lots of cameras, determining how much storage space you need can get quite complicated. You could use a storage calculator, or you may need the help of a security professional to help you determine all the variable settings. The other need you might have is determining the bandwidth needed for your security camera deployment. This can be just as complex and may require the help of a security professional to determine your overall bandwidth needs. I've added a link to a simple storage and bandwidth calculator that LENSEC provides on its website here at the bottom. So we've fit a lot of information into a little bit of time, and I'm sure we have some questions out there, David.
Yes, several questions have come in. Let me just gather those up real quick, and looks like we've got a little bit of time to get through a few of them. And see what I've got here. Here's a good question, Keith. Why would an IP camera have a BC connection, a BNC connection on it?
BNC connection, as we mentioned early on, is a connector that provides capability to connect to an analog device. So one of the main reasons that an IP camera or even a megapixel camera would have a BNC connector is so that when you're setting up that camera, you can connect what they call a spot monitor directly to it. And a spot monitor can be used for two different things. Most of the time you would use it. Most of the time you would use it to either connect a public view monitor nearby the camera, or a better idea is to use it to help set up your camera during installation. So you can connect a small monitor to the device, be able to focus and point the camera and make sure your field of view is right before you walk away from it. Otherwise, you have to use the IP signal, the network signal, to be able to make adjustments on your camera view. So those are two very good reasons why an IP camera might have a spot output BNC connector on it.
Okay, sorry about that, Keith. The other line was ringing. Another question here. What is an IR cut filter?
An IR cut filter is used on true day-night cameras. It helps to change the mode from day to night using a mechanical cut filter. This is a more precise way of providing good images either in the daytime or nighttime. Most cameras today are using a digital day-night mode, but a camera that's a little nicer or wants a better clarity of image might use the cut filter. This is a filter that moves between the camera lens and the image sensor. The photosensor that measures light levels indicates when the cut filter should activate. So during daylight hours, the filter is in place, and you've got an excellent clarity of color and image. it blocks infrared light and only allows visible light to reach the image sensor. When the light levels drop to dusk, the filter moves out of the way, changing the camera from day mode over into night mode. Now infrared light can reach the image sensor, and the camera has a better capability to see images. It'll switch the camera into a black and white mode, which is more sensitive to infrared light. And then the camera using the IR cut filter would be considered a true day-night camera.
Thank you, Keith. I think we've got time for one more question here, and then we'll wrap it up. We will follow up with answers to all questions submitted via email. But Keith, there's another good question here. Is it better to have a proprietary video compression or an open format?
That's important and comes up a lot, in particular when you get to law enforcement officers that are planning investigations. It really depends on how you're going to use that video once it's extracted. Some law enforcement prefer a proprietary format because it ensures the video hasn't been tampered with. Most prefer an open format. So what that means is proprietary format video is presented from the VMS or the video management software in a proprietary format and can only be viewed with a proprietary player. An open format capability means the video can be offloaded and viewed through Windows Media Player, or another one that I like is VLC Player. That's a really good one. Those play open format videos. And so oftentimes when you have a recorder that records in a proprietary format, they might have a way to convert that over to an open format so that you have the capability of going down either path. In these cases, the VMS provides a way to convert the video to an open format. Most people prefer the open format because it ensures the ability to play the video anywhere in the foreseeable future.
Okay, thank you, Keith. That'll wrap up the presentation portion of our webinar.
David, I have one extra point. David, I have one extra point I'd like to make sure I make, and that's on the megapixel lenses. We didn't cover that very well. We just touched on it briefly. If you have a megapixel camera, make sure you're using a megapixel lens that's rated for the type of resolution that you're trying to achieve. You can't just put a standard lens on a megapixel camera and achieve the same kind of quality. The megapixel lenses use a better grade of glass that's highly refined and will really enhance the quality of the picture. So you want to make sure you do that when you're using megapixel cameras. That's an important point to bring up.
Good point, Steve. Anything else, and then we'll wrap it up.
That's it. Thank you.
Okay, so I'd like to remind the attendees to complete a quick survey at the end of the webinar. On the survey, again, you can request the completion certificate for this webinar. We'll email out the items promised, the webinar archive, answers to question, presentation, and so forth. The webinar recording will be posted to our video archive on the LENSEC website, which is lensec.com, LENSEC.com, along with previously recorded webinars covering a variety of topics related to physical security. I'd like to take one last opportunity here to thank Keith Harris for putting this together and presenting on IP security camera surveillance techniques. My name is David Martin with LENSEC. You'll have both mine and Keith's contact information posted there in front of you with our phone numbers and email address. Please feel free to contact me at any time for any questions that you may have or any assistance that you may need. That does wrap up our webinar. Again, thank you for attending, and we'll see you again next month with the next installment of our Step into Security webinar series. Thank you.
Thanks, everybody.